Hello friends, this is Durga from itversity. I hope you guys can see my screen. So this is primarily about submitting the jobs on EMR cluster. You should already have some level of Spark and Scala skills. If not, you will struggle a bit to understand. This is only for those who already familiar with Scala and Spark and who want to add EMR to their profile. That being said, we will start with prerequisites. I will go through the prerequisites that are required to go through this exercise. Then we will talk about recap of application development lifecycle. Then we will define a problem statement. Then I will briefly explain setup, project, and dependencies. I will not be spending too much of time on this because the assumption is that you already know about this. But just to make sure that you recollect, if you are not working on Spark extensively, you should be recollecting what is this all about. So I will spend briefly some time about how to set up project and add dependencies, etc. And then we will get into develop application. I will not go through step-by-step process of developing the application. You should already have certain level of knowledge with respect to Spark data frame APIs. If not, you have to review other courses and then you have to come back to this again. But I will highlight some of the things to just make sure that you understand why certain APIs are used as part of this. Then we will be validating using IDE. I just want to make sure that you understand the relevance of using IDEs locally before moving on to the EMR or any other clusters which are used for production. So I will again reiterate how to validate local using IDE, and also will build and validate jar file. After that, we will get into the deployment on EMR cluster. Let's assume that EMR is our production cluster. Then what is the step-by-step process to actually deploy in our production cluster, which is on EMR. So we'll talk about uploading jars to S3. S3 is AWS cloud storage. I will get into those details at the time. And then I will recap about basics of setting up EMR cluster so that you recollect from that aspect also. And then we will actually talk about how to deploy jar file using step execution. That is part of creating EMR cluster. Whether you use step execution or if your EMR cluster is running all the time, the steps are almost same. You should follow similar steps to actually execute on the EMR cluster. Once you are familiar with the step execution, you should be able to pick up the other aspects also. Then finally, once the job is submitted, you should be familiar about how to troubleshoot in case if there are any issues. So what are the prerequisites for this? As we'll be using EMR to deploy the application, there are some prerequisites which we need to keep in mind. You need to have a valid AWS account. You also have to share your credit card as part of your AWS account, but you will be charged only pay as you go. Many people might get tempted to use free tier, but I don't recommend to go with free tier. And don't waste too much of time with respect to free tier when it comes to EMR. Just spend that few bucks and make sure you get a decent cluster and validate your applications against it. So you need to have valid AWS account, which require your credit card also. Then you have to have S3 bucket setup. So when it comes to real world scenario, we will have multiple buckets, one for input data, other for output data, because by nature, EMR clusters are supposed to be ephemeral, which means we should not maintain our data within the EMR cluster. There are exceptions to it, but in general, we try to make EMR cluster ephemeral so that we don't have to pay to AWS if the cluster is not in use. As the philosophy is pay as you go, most of the EMR clusters are ephemeral and we don't store any data in EMR cluster itself. One of the storage is S3, which is nothing but AWS cloud storage, or it can be a database like Redshift or DynamoDB, whatever technology you want to use as per your as per your project. For this, I'm using S3 itself. We'll be processing files from S3, and we will, after processing the data, whatever the output is, we will be writing it back to S3 again. Typically in a actual project, if you are using AWS, there will be a separate bucket for input, separate bucket for output data. Also, you have to upload the code or compiled code. so that it can be run on the EMR cluster. So we need to have a bucket even for directories. Don't mix up the directories for data and the directories for the jar files or your compiled code. You have to have a separate bucket for the compiled code. So in this case, I'll be using two buckets. One is S3 ://itversity data, where I'll be having the input directories as well as output directories. Let me review real quick so that you understand what I'm talking about if you are a bit new to AWS or if you are not working extensively on AWS. So here I'm connecting to my AWS account. And I'm taking you to my S3. There are so many buckets here. So I'll be using BD Cloud Demo, which will be the one which where I'll be placing my jar files before submitting the application. Already there are a couple of jar files. Let me delete these things so that we actually see that whatever I'm demonstrating is working fine without any issues. So I'm deleting these two jar files, and I will be uploading again at a later point in time. Also, if you go to my S3, so BD Cloud Demo is the directory which I'll be using to place my jar files. And also there is a bucket called as itversity data. Already I have uploaded the retail DB dataset here. So this itversity data is the bucket which we'll be using for both input as well as output. So if you want to use the same dataset, here is the link for you. It's in my S3, sorry, not S3, but GitHub repository. You just have to clone this repository. I have provided instructions here. And once you have on your PC, you should be able to upload into S3. You can open the S3 console and you should be able to drag and drop the entire folder into that. And you will see the files which I'm using here as part of your S3 bucket also. So yeah, now let's get into the recap of application development. We have completed the prerequisites. We need to have a couple of S3 buckets and a valid AWS account, and we are good to go. Typically, once you sign up for AWS account, once you give the credit card, you will have limited or you will have capabilities for limited size clusters. You will not be able to build very big cluster. You have to get prior approval for doing so. But for our demo purpose, whatever default capabilities we get are good enough. When it comes to application development, I just want to reiterate the application development lifecycle here. First, we need to set up development environment. We might have to have local Spark setup so that we can validate the jar files before uploading into the whatever cluster in which we want to deploy. It can be EMR cluster as being demonstrated today, or it can be our labs also. Our labs also a multi-node cluster. If you want to validate your jar file, considering our labs as production cluster, you should be able to ship the jar file to there and you should be able to validate. Even before that, it is a good practice to validate the jar file locally. For that, we need to have local Spark setup. Then you need to have IDE. It can be Eclipse with a Scala plugin or IntelliJ. I'll be using IntelliJ for the demonstration. Also, along with your IDE, you also have to have Scala plugin. Without Scala plugin, you will not be able to build the Scala-based applications using the IDE. Also, you need to have build tools such as SBT. If you are using IntelliJ, when you add Scala plugin, SBT also comes with it. And you should be able to use SBT-based build process for those projects. And I will demonstrate how to make appropriate choices to choose appropriate tools for our project at a later point in time. But you need to have these things first, sure, before you get into the development. Then we need to define a problem statement. It can be your project or it can be a basic problem statement for learning few things. Then we have to develop application using appropriate APIs. In this case, it is nothing but Spark-based APIs. Then we have to validate locally using IDE. Then we have to build the jar file and ship to the cluster to deploy. And for today's demonstration, we'll be using EMR cluster. When it comes to problem statement, we will try to compute daily product revenue for complete or closed orders. So the requirements from business will come like this. Hey, we have retail data. I want to compute daily product revenue. Um, Sometimes the requirement might not be even complete. Then as a developer or as an architect, we have to ask the business, hey, you are saying compute daily product revenue. What is the definition of the revenue? Do you want to consider all the orders that are placed, or do you want to consider only specific orders? Because when an order is placed, it can be complete, it can be closed, it can be pending, it can be new, it can be being shipped, it can be cancelled, or it can be defaulted, which means you sent a product, but or you sold a product, you shipped it to the customer, but customer did not pay to you. So there can be different statuses for a given order. Then business will definitely come up with more specific insights, and you have to consider that before getting into the design and implementation. So in this case, we want to consider only complete or closed orders to compute the daily product revenue. So let's get into the data and understand how we can actually solve this problem. So once you clone the GitHub repository, which is nothing but our data repository, you will see a directory locally in your system, something like this. So in my case, I have cloned the repository into this location: users, itversity, research, data, retail, DB. Once I clone, I see these 6 folders: orders, order items, departments, customers, categories, products, etc. So to compute daily product revenue, I don't want to get into the data model and explain all the aspects. I will just narrow down that. Once you also go through the design process, you will identify what all tables should be used or what all data sets should be used to solve this problem. So I came to conclusion that I have to use orders and order items. So let's review what orders have. So in this case, I'm opening the file in orders, and you can see that it's a text file where you have alphanumeric characters. And if you look at the characteristics of this file, and there are lines, and each line is something like a comma separated record from some source database. So each line is a record here, and each record is delimited by comma, and we have 4 fields, and those are nothing but order ID, which is the primary key, then order date, which is nothing but the date on which order is placed, then customer ID, and then status. And what our problem statement says, it says daily product revenue for complete and closed orders. So here you have the status, because status is the order level attribute, and also you have date. So you need to have these 2 fields, date and status. Status for filtering for complete or closed orders, and date for daily product revenue. But you don't have product ID or revenue in this. So we have to identify which table provides the data. And I have already identified it is nothing but order items. So let's review order items also. If you look at this, there are 6 fields in each record. The first one is order item ID, which is nothing but primary key field in this dataset. The second one is order ID. So this is foreign key to orders.order ID. Earlier we have seen orders dataset, and the first field is primary key for the orders dataset. In this case, the second column actually refers that first column in orders, and hence there is a logical relationship between the second field and the first field in orders, and it is nothing but child to parent relationship. So this is child and that is parent. The reason why it is important to identify this is because orders have date and status, and also order ID. Order items have order ID and other information which is required to compute daily product revenue. So we have to join these 2 tables, and we need to identify what are the keys we should be using to join. So in this case, it is nothing but order ID. So we have order ID as second field, and the third field is product ID. So we need this because we are trying to compute daily product revenue. And the fifth field is the order item subtotal. So for each and every item, how much revenue is being generated. If you look at these 3 records, there are 3 items for order ID 2. And if I want to compute daily order revenue, not daily order revenue, but order revenue, I have to group by order ID, and I have to sum up these three values to get the order revenue. But in this case, I want to get daily product revenue. To get daily product revenue, I have to use date, which is in orders, and the product ID, which is here. And for each date and product ID combination, I have to aggregate using this order item subtotal. So that's how we should be able to get daily product revenue for complete or closed orders. So that is what we are trying to do here. We will try to filter the complete or closed orders. Using the order ID for complete or closed orders, we will be going to order items. We will join with order items, and then we will group by date and product ID, and we'll compute the daily product revenue. So let's get into the implementation aspect of it. So first and foremost, we have to make sure that the project is set up and dependencies are defined. If it is existing project and if you are adding a new API or new function to solve a problem, you can skip this and you should proceed with the implementation. But if there is any jar file missing, you have to add that jar. For this simple application, you need to have at least 2 jars that needs to be added as part of the build.sbt. I will explain what is that in a moment. And then we can actually proceed with the development process. First, I will start with a recap of how to create a new application, and then we will actually take it further. If you're a bit new to the Spark-based application development, or if you're not working on Spark on day-to-day basis. So here, I am using my IntelliJ IDE. Already, I have set up the project here. You can see everything is ready. Okay, whatever I have explained in that, it is already defined here. However, if you want to start from scratch, you can go to File, New, Project, or when you launch IntelliJ, if the window is like this, you can actually say Create New Project. Okay, if you are using for the first time, it might be pointing to Java, and there is a Scala here. Few people might actually try to choose this. Don't do that mistake. Never do that mistake. You have to choose Scala, and you have to use SBT as a build tool. Okay, so these choices are very important. Then you can click on Next. For newbies, this window is very, very important. You have to give the name for the project. You have to ensure that JDK 1.8 is selected. When it comes to SBT, you can choose the latest version. But when it comes to Scala, depending upon the Spark version you are using, whatever Scala version is compatible with that, you have to choose that. So how to decide on Spark version? First, you need to do the analysis about what is the Spark version that is being used in our production cluster. In this case, let's assume EMR cluster. Depending upon the Spark version that is being used in EMR cluster, you have to choose. If you want to deploy the application in our labs, you have to go to My Labs and check what is the Spark version we have there, and you have to choose the compatible Scala version here. Don't choose the latest Scala version directly. It is very, very important for you to understand this. Otherwise, you will be running into class not found exceptions, and for newbies, it might be a challenge to troubleshoot such kind of issues. That being said, let's do that exercise about how to choose the Scala version. You need to make sure that you pause here, you really understand how to make the decisions, and then take it further. Don't rush here. It is a very, very important step which will save you a lot of time if you are completely new to this application development. So let me go to my AWS services, and let me choose EMR. If you are not sure where is EMR, you can just search for it. Or as part of the analytics, you will see the EMR. So you can click on after searching, or you can directly go into analytics and you can actually choose. You can click on create cluster. Okay. And then you have to choose the releases. Okay. So depending upon the EMR release you are choosing, it will actually show what is the Spark version that is being used. And if you look at this, Spark is 2.4.4. Okay. Now we have to identify which Scala version is compatible with Spark 2.4.4. For that, what you are supposed to do, you have to go to spark.apache.org. Okay. And then you go to the latest release documentation. So here I have gone into the documentation with respect to Spark 2.4.4 release. So I'm showing once again, because this is very, very important step. People might rush and then they might end up in loops, and it can cause some issues. So spark.apache.org is the page. In that, go to documentation, make sure you select latest release. Then you can actually go to the downloading part here, okay? And you can actually see what is the version of Scala that can be used. You can read this through. Spark runs on Java 8, Python 2.7 or 3.4 plus, and R, if you are using R, it is 3.1 plus. For the Scala API, Spark 2.4.4 uses Scala 2.12. You will need to use a compatible Scala version 2.12.x. Support for Scala 2.11 is deprecated as of Spark 2.4.1 and will be removed in Spark 3.0. So if you are using Spark 2.4.4, you have to use Scala 2.12. You can use the latest version of Scala 2.12. Okay, so that is how you should choose the Scala version. So in this case, the most appropriate version is the latest version of Scala 2.12. Let me give a different name here, Spark 2 live demo. Okay, and then let me finish. Okay, let me do once again, let me cancel this, and I'm creating new project again. And next, Spark 2 live demo. And then I have to choose the 2.12.10 and I can say finish. So my existing code base is on 2.11. As you can see, as part of the material in the documentation, even with the Spark 2.4, 2.12 is supported. Sorry, not 2.12, but 2.11 is supported, and hence we can use 2.11 also. But if you're just starting new, make sure to choose the Scala 2.12, and it will work without any issue. So someone is asking, what about if I have Spark 2.2 version? So you have to do the same exercise. You have to go to the documentation. Let me point you here. So what you should do is go to spark.apache.org, go to documentation. Instead of going to latest release, go to older versions and other resources. Scroll down. So let's say your version is Spark 2.2.3. Click on this, and they have done the similar thing here. So 2.11.x is the appropriate Scala version. So this is how you should be able to get the information. You don't need to be relied on me or anyone. Just go through the formal documentation for the given release and you should be good to go. Once again, I'm reiterating because this is a very, very important step. You just go to spark.apache.org, documentation. If yours is not a latest release, click on older versions and other resources, go to the appropriate version and take it further. Okay, I hope it answered your question, Jajati. If not, please post it on comment and I will see and respond to you. Okay, that being said, this is how you should be setting up the project. Once this is done, you can actually go here, go to build.sbt, and then you can actually add the library dependencies. Let me go through the material here. Just give me a moment. I think I lost the track of my material. Yeah, it is here. So I just have to add these things. I will explain why I'm using typesafe config in a moment. Okay, now we have added these two dependencies. It will take some time to import the jars, and then you should be able to use the APIs related to Spark. The way you can confirm whether the jars are imported or not, you can expand this and you should see all the jar files here. After the download is done, you will see all the jar files here. Okay, And then you can confirm that they are downloaded, and you can actually have a sample program and try to import awk.apache.spark.sql.spark session. If everything is downloaded properly, it will confirm that the APIs are available for you. That being said, what is the purpose of this one? So when it comes to projects, we will be developing on our system using IDE. Then we will be shipping it to dev cluster, QA cluster, production cluster. There might be more also. In each and every cluster, the paths can be different from where you are developing. For that purpose, we have to provide the paths which are specific to environment. The beginners might make a mistake of hard coding the paths, which is not good. Either we have to pass them as arguments, or we have to pass them as external properties. If you start passing the input path, output path, etc. as arguments, then the program will become clumsy. More than program, the runtime arguments might be too many, and it might become clumsy from the support perspective. To avoid that, we typically externalize the properties, and the externalized properties will contain input paths, output paths, which are specific to a given environment. We might also have database related information such as host on which a database is running, username, password. Everything will be in that externalized properties file. As part of Spark, not Spark, sorry, as part of Scala-based application development, if you want to load the properties which are externalized at runtime and use them, there is a plugin called as typesafe config, and we will be using that. That is the reason why we have this additional package added here. So for now, we have only these two dependencies which are required for our today's demonstration. So make sure you add these things. Okay, so there are few questions with respect to not question, few questions. There is one question with respect to Python. I will not be taking too many questions with respect to Python because this is more of a Scala-based approach. However, the question itself is not correct, Alok. So Python is an interpreter-based programming language compared to Scala, which is a compiler-based programming language. So there is no process of build with respect to Python. We will not build the Python code into a jar file. Most likely we will create a zip file with all Python scripts, and we will ship the zip file and we will deploy. Okay, so the terminology is not correct. We will not be using build tool for Python-based approach, because Python is an interpreter-based programming language. There is no process of compiler in between. Whereas Scala is a compiler-based programming language, and hence we can use it and we can take it further. Chandra is asking, can I use the typesafe config even in cluster mode? Very good question, Chandra. Yes, you can use, but it is a bit tricky. I will not be able to cover that as part of today's session. But there is a way to do so. You should be able to use typesafe config even in cluster mode. Very, very good question. Probably I will have another session about it. You can actually ping me on Slack if you are part of our Slack channel, and I will be able to provide the answer for that for now. But I will not be getting into the details with respect to using typesafe config in cluster mode. And whoever is asking questions, please click on like if your questions are clarified. That way it will give me some traction. Okay, so that being said, so we not only have to define this typesafe config as part of the dependencies, we also have to define the properties in a standard location. So one of the way you can use typesafe config is by creating a properties file under source main resources. So we have to create a directory called as resources here, and then you have to use certain standard names for your file names. One such standard name is application.properties. The other standard names are nothing but application.conf, application.json, etc. If you want to get more insights about it, you can just search for type safe config GitHub, and you can click on the official repository for type safe config, and you can go to the material. So let me tell you what are those standard names which it accepts. Yeah, so these are the standard names. And as long as you are using the standard names and you are creating file under source main resources, you don't need to pass the path to actually load at runtime and get the solution. So Sufia is asking the difference between Spark 1 and Spark 2. I will not be able to answer that question. It will distract the whole conversation. Today's session is about AWS EMR submitting Spark jobs. So let's stick to that agenda. Okay. Probably if there is a demand, you can actually get into my Slack group and you can raise this demand, and I will try to conduct a session on top of it. Okay, because there will be too many requests for me, and I have to make sure that the request which is in demand is addressed. Otherwise, it will be overwhelming for me. Anyway, to answer your question, Sufia, it is a bit out of context for today, so I will not be getting into those details. So now if you look at the pattern of these file names, sorry, not file names, but the properties names. So there is a prefix for these three properties which says dev. Okay, and there is a prefix prod for these properties. After the first keyword dev or prod, the rest of the name is same. So you have execution mode for dev, execution mode for prod, input based directory for dev, input based directory for prod, output based directory for dev, output based directory for prod. So you have to provide the names like this, and depending upon your environment, you have to add the location of your retail DB directory here, because I am passing base directory, and as part of my code, depending upon which dataset I am trying to process, I am appending orders or order items to it, and then I am processing the data. So that's why I named it as base directory. So this is the base directory for my input, and this is the base directory for my output. Once I validate, it will actually write the output to this location. When it comes to prod, in this case, I am considering my EMR cluster as prod, and in EMR, this is my input directory or input base directory, and this is my output base directory. So like this, you have to define the properties. So this is how you can actually set up project and the dependencies, and also add the required properties so that they can be loaded at runtime and used as input and output. This way, we don't need to refactor when we push the code to different environments. Now, when it comes to developing the application, I just have to create, I just have to modularize my code. Typically, in most of the projects, what we'll do is we will create separate package for input, separate package for output, and separate package for processing the data. But in this case, because it's a simple application, I'm just using one package, and I am actually writing the complete code over there. And also for each and every jar, there should be an entry point, which should have main function. And from there, depending upon the use case which you are trying to use to process the data, it should be smart enough to choose the appropriate programs and run those programs. You should not have the main functions in each and every Scala class as I'm demonstrating today. That is not a good practice. You have to modularize the code in a more structured way. But it will be overwhelming if I start doing it as part of the trainings. That's why I don't cover those things here. I will just create one package and one object or Scala file, which will contain the whole logic. So in this case, you can say you need to right click on source main Scala. You need to ensure that you are on the Scala folder. It should be highlighted like this. Right click, new, and then go to Scala class. Make sure you choose object, because in Scala, objects are the ones which will contain the main function or main method. For that reason, you have to choose object, and then you can give the name. However, I want to first create the package. So let me create the package here. The package name is nothing but, let me see here, retail_db. You can see that there is a folder created under source main Scala by name retail_db. Now you can say new Scala class object, and then the object name is nothing but get daily product revenue, and hit enter. Now you can define the main method here, and you can take it further. Okay. So let me copy paste this code. As I mentioned to you earlier, I will not be spending too much of time in explaining the entire code. Typically, I develop the code in the live sessions, which I'm not going to do today because this is a bit advanced session for those who already know Scala and Spark up to an extent. So I'm just copy pasting here. Okay. The code is automatically formatted, even though it is not well formatted in the in my blog. I will address that at a later point in time. Now, if you look at the code, the first thing what I'm doing, val props equal to config factory.load. What is this config factory? It is nothing but a class or object or whatever it is under package com type safe config. Okay, so it is a method called as load, and we are not passing the path. Even though we are not passing the path of the file, as we have application.properties under source main resources, it will be automatically loaded here. To answer Chandrakant's question, if you want to do it in the cluster mode, what you are supposed to do is you have to pass your properties file using -- files. After giving the path, you have to give the alias by saying hash, something like this. So let's say the file name is under U01 conf. Okay, for your application properties, let's say this is the standard location where you will be deploying the properties files, and let's say application.properties is the file name. So what you are supposed to do is when you do Spark submit, you can use -- files. As part of the files, you can pass this path. If you are using cluster mode and if you want to read this file as part of your code, you have to say hash, and then you have to say application.properties. Okay, and then you have to use this name as part of the load, something like this. Okay, then it will automatically pick this file and it will try to fetch the information, pass it to that file. So that is how you can take care. So just to give you quick hint about how it will work. Okay. So as we are bundling the properties file as part of the code itself, in this case, we don't need to do it. We can just say config factory.load, and we can actually pass the, we don't need to pass anything. It will automatically load from source main resources application.properties. And then if you recollect, as part of the application.properties, we have this prefix for each and every property, which is related to the environment where we are running, like dev, prod, QA, UAT, whatever environment it is. That one needs to be passed as argument, so that using that argument, it loads the properties related to the environment. Okay, so that's where this args_0 comes into picture. When I say props.getConfig args_0, it will actually load the, if I pass dev as argument, it will load these three properties, like execution mode, input based directory, output based directory, etc. If you are not sure how it will work, if you are not sure how it will work, what I will recommend is you can read the properties using the respective APIs and print on the screen, and by passing dev, by passing dev.execution, etc. And you can see that how the properties or this variable is actually built, what all values you will have. In this case, this env props will be having these three properties without dev. It will only have execution mode local, input based directory, blah, 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 output based directory, blah, blah, blah. That's where when I try to specify the execution mode, I'm just saying execution.mode. I'm not saying dev.execution.mode, because env props, as we have already passed dev.prod here, it will only contain the remaining information such as execution mode, input based directory, output based directory, etc. And we are trying to read the value for that property related to the environment in which we are running. Okay, and then this is primarily the code which will build the Spark object of type Spark session, which will expose the APIs to read the files. When you actually build the Spark object programmatically like this, it is important, if you are using Scala as a programming language, to import spark.implicits, so that when you actually develop the logic, if you want to use $ as the operator instead of using call function, you will be able to do that. Otherwise, you will not be able to do that. If you know Spark data frames and all, you should be able to understand this pretty quickly. I am not going to get into too many details here. You can go through this code at a later point in time, and if you have any question with respect to this code, you can definitely ask. So that being said, Spark, which is of type Spark session, exposes APIs such as read to read the files. And this is where I'm actually passing input based directory, concatenating with orders to read the orders dataset. And I'm defining the schema here. If you recollect, orders have 4 fields. That's why I have defined 4 fields with appropriate data types. Order items have 6 fields. That's why I have defined 6 fields with appropriate column names and data types. And again, here also I'm using input based directory, and then I'm concatenating with the /order items so that I can read the order items dataset here. Now, first and foremost, you need to understand how we should actually process the data. So when it comes to the solution for a given problem statement, we might have to filter the data, we might have to join, we might have to sort, we might have to do several things in between. Typically, the filtering should be done as the first step in the data engineering, sorry, not data engineering, but data processing lifecycle. You should typically start with filter. You should filter as much as you can. Then there might be several APIs. Depending upon the use case, you might have to join first and then aggregate, or you might have to aggregate first and join. It can be in any order. Depending upon your requirement, you have to do some trial and error based on the characteristics of your data. And when it comes to sorting and ranking, you should consider it as part of the last step. So the first step should be typically filtering. The last step should be sorting or ranking before writing into the target file system. In between, depending upon your data characteristics, you should be able to come up with the logic. So in this case, I just filtered the data first, then join with order items based on order ID of orders and order item order ID. Then I'm grouping by order date and order item product ID, because this is what we have decided to compute daily product revenue. And then I have used the aggregate function to use sum and then round, so that the data is rounded to 2 decimals. And I am giving alias as revenue for this. And then I'm sorting the data by date and revenue in descending order. So this is the logic to solve the problem. Just 4 lines of code, not much. Once that is done, I am reading the output based directory, and I'm writing the output into the JSON file format. Here, if you look at this, I'm saying mode overwrite. So if the target folder already exists, it will be overwritten, and you should be able to see the replaced dataset in that. So this is how you can develop the code. Make sure when you try to implement this in your project, make sure you modularize the code by dividing into input or read, output or write, and then processing. Have different packages for that, and have the logic in appropriate packages. Don't write the entire code like this in actual projects. It will be maintenance nightmare over a period of time. You will be lost if you want to add more and more modules to your application. You need to ensure that code is properly modularized. But for the demo purpose, I just wrote everything in one. Okay, so keep that in mind. So in this case, Rags, he's asking how to handle dynamic columns for taking up the schema as you just showed. So in this case, I'm just passing the column names as a string. So this is of type string. So you can build string like this This is one way to do so. Typically, we get the column names and data types in a control file. You have to load that control file as part of your program, and then you have to build this string. This is one way to apply the schema. You can do it dynamically. Another way is there is a special type called a struct type. So you have to use struct type and struct fields to actually build the schema based on the columns which are passed through the control file. So those two are the approaches which you can take. I hope that answers your question, Rags. If you have any follow-up question, you can ask in the chat. I will definitely answer that. Okay, in this case, if you observe, the schema is passed as string, and you can build this string using the information passed through control file. So now the code is built. Now we have to validate using IDE. Once it is run using IDE, then we can take it further. So what I'm trying to do here is, let me go to the output path, which is defined here. The output path in my local environment is nothing but this one. Okay, it is not there. That's good. Let me check. Let me check if it is there or not. Okay, there is a Scala folder here. Then there is a daily product revenue. So, okay, so in this case, we have a Scala folder, but we don't have Scala here. So whatever output path will be, it will be directly under this folder. Once I run this, there will be a folder by name daily product revenue under the output base directory, which is specified here. So if you go back here, under this location, you will see a new folder. Okay, sorry, not this one. I have to use CD, and let me copy paste this, and then let me run ls-ltr. So you will see a new folder by name daily product revenue here. So now let me go back here and let me run this. As it is a new project, when I run this, it will fail. The reason is, if you look at the code, it is expecting an argument, but I haven't passed any argument to this, and hence it will fail. Okay, you can run it without failing also, but you have to go create the configuration for your run, which I will show in a moment. This is one kind of a hack where you just run it, and as part of the run, edit configurations, you will see the application directly. If you don't run and directly, if you go to run menu here and click on edit configurations, you will not see this application. So just to this to get this pre-populated, I just ran it even though I know that it will fail. The reason why it is failing, because if you look at the code, it is taking one argument, args of 0, and I haven't passed any argument. So that's why it failed. And if you look at the exception, it says array index out of the bounds exception. Okay, and it is checking for the first argument, which is represented by index 0. Now I can go to run and then go to edit configurations. So if you do not run and if you directly come here, it will be something like this. You will not be seeing that pre-populated. If you don't want to fail and if you want to create that application for whatever reason, you can click on plus here, go to application. Then you have to choose the main class which you want to run. So I want to run this. If you have multiple main classes, it will show the list and you have to pick whatever you want. And we can give the name. So let me give the name as get daily product revenue here. This name can be anything. And then you have to make sure that the class path is chosen here with your project. And then you have to pass the program argument. What is the program argument? In this case, it is nothing but dev. Now I can say apply and OK. So earlier, when I directly run without having the program argument, it failed, but it have built all this information without this program argument, and we can directly enter the program argument, and then we can say OK, and we have to right click on this, and then we can say run. It will run and read the data from the input directory which we have passed, apply the processing logic, and the output will be returned to the target location, which is nothing but this one. So we can see retail DB folder in EMR demo. So I can go to CD retail DB. And then you can see the daily product revenue. The reason why it have created retail DB also, if you go to application.properties, I said research data, EMR demo, retail DB, and then we have the uh, target folder, which is defined here, which is nothing but daily product revenue. That's why you have the retail DB folder. In that we have the daily product revenue. We can go to the daily product revenue here, and then we can actually look at the file. And you can see the JSON data. As I have round after summing, you can see that the revenue is rounded to 2 decimals. And also, as part of the final step before writing, I have actually sorted data by date in ascending order, and then by revenue in descending order. That's why you can actually see the revenue in the descending order, and the top selling product or top sold product for the date of 2013 July 25th is with ID 1004, and the revenue is this one. If you want to see the name instead of product ID, then you have to join this with the products and you should be able to get the name. But in this case, to keep it simple, I went up to product ID only, not till the name. Okay, so this is how you can validate using IDE. Now, if you have Spark locally, you can build a jar file locally and you should be able to run it locally. Then you can actually ship it to the cluster and then deploy it on the cluster. This is a very, very important step to understand how and what all arguments we should pass when we ship it to the cluster. So if you look at this, I have Spark shell already set up. I have Spark already set up in my local machine. And I'm just launching Spark shell to make sure we understand which version of Spark is already there. To submit the jobs, we have to use Spark Submit, and we have to pre-build the jar file, and we have to pass the jar file to it, which we'll be doing in a moment. You can see that the version of Spark is 2.4.4. However, as of now, the Scala version, which is being used for the Spark which I have downloaded, is 2.11. And hence, there might be an issue when we run Spark Submit, because if you look at the code, or if we look at the build.sbt, the Scala version is 2.12, and the Spark which I have set up locally have Scala 2.11. Okay, so we have to be a bit careful here. If we have this kind of conflict, again, we have to go to the EMR console and see if it actually provides any information about Scala. So it doesn't provide any information about Scala. It might be primarily 2.12, but with our basic code, it doesn't matter whether we have 2.11 or 2.12. Both should work without any issue. When we get into Spark 3, when they stop supporting 2.11 Scala, then we might run into any issues. But as of now, whether the Scala version is 2.11 or 2.12, it should work with my basic code. That being said, let me come out of this. And before running the Spark Submit command, I need to build the jar file. How to build the jar file? There are multiple ways to do that. We can use IntelliJ itself to build the jar file, or we can also right click on this by saying, sorry, you can also right click on this and then say copy path. Let's say absolute path. Then go here, CD, paste. It will take you to the working directory. If you have SBT also locally set up, then you can run SBT package. But if you don't have SBT set up, it will say command not found. You don't need to install SBT explicitly. If you actually go to run, and if you go to edit configurations, as part of this, you can click on plus, and you should see SBT as an option here. Let me see if SBT task. You can click on SBT task. You can give the name. Let me name it as Spark 2 live demo. So in case if you don't have SBT set up on your PC, make sure you use IDE and build the jar file. Then tasks, I think, is package. And then say apply. I didn't do it recently, so it might fail, but let's see. Now you can run this, and most likely it will work, but we will confirm. If you have SBT locally set up, it's pretty straightforward. You can go to the working directory and you can run SBT package here, and it will build the jar file under target, then Scala. Okay, it didn't run yet, completely yet. That's why. Yeah, so this is the location you can see here. Now the jar file is built, and if you look at this, there is a target Scala 2.12, etc. So now let's say ls-ltr target Scala-2.12, and you can see the jar file here. And if you look at the naming convention of the jar file, this is nothing but the project name. This is nothing but the main version of Scala, which is 2.12. This is nothing but the application version, which is nothing but 0.1. If you go to build.sbt, 2.12 comes from here, 0.1 comes from here, and the first part of the jar file comes from here. So using these three properties, it actually built the name for the jar file. Okay, so that being said, even if you run SBT package here, if you have SBT locally, by going to the working directory of the project, it will create the jar file. You need to make sure that you are in the right directory though. One way to confirm is you can actually run ls-ltr in this directory and make sure you have build.sbt. You can also review the contents of the build.sbt, make sure the project name, version, and Scala version are correct, and you should be able to take it further. Now we can run the Spark submit command like this, Spark submit. Okay. We don't need to master, we don't need to pass master, because by default it is local only when we run with a local Spark setup. But we have to pass the class. What is the class name? It is nothing but the package name, retaildb dot get daily product revenue. Okay, and then we have to pass. So one thing you need to remember is we have two types of jar files. One is Spark related jar files, and other one is this third-party jar files. When it comes to this third-party jar file, it will not come with come along with the Spark. Spark will only have certain jars, and when we use those things to develop the code, even though when we build the jar file, even if you don't include these Spark-based jars, it will work without any issues. Let me explain in a bit different way. If I go to target and then Scala -2.12, and if I say jar tvf and pass the jar file, you can see that the jar file contain only two classes. One is get daily product revenue, and the other one is get daily product revenue $.class. If you understand Scala, when you define object, it will have a companion class. That's why you can see two classes here. This is due to the Scala one, but you don't find any other classes here or jar files here. You only have these things. When I run this without third-party plugins like typesafe config in a cluster, as the cluster will already have the Spark-based binaries deployed on all the nodes in the cluster, it will work without any issues. But when you start adding the third-party jars, which might not come with the Spark, and if it is not available on all the nodes in the cluster, it will fail. So in this case, what I'm trying to do is I'm saying Spark submit. Okay, and the class is nothing but retail_db dot get daily product revenue. Let me delete this part. Okay, and I'm not adding any additional jars, but I'm actually passing the jar file, which is nothing but target Scala -2.12, and then Spark to live demo .jar, and I want to run in dev mode, and hence I'm passing the argument dev here, because our code, this object get daily product revenue takes one argument. If you see, it is saying no class definition found typesafe config. So we need to pass the typesafe config as part of our submit command. The way you can do it is you can say Spark Submit -class. Let me type once again, Spark Submit -class. Let me copy paste this. These third-party jars can be provided in two ways. One, by using jars. Two, by using packages. When you give packages, you have to give the group ID, artifact ID, and the version. So if you go to build.sbt, the group ID is nothing but com.typesafe for this dependency. Then we have to separate with colon, then artifact ID, then the version. Okay, so this is how you can actually pass using packages. When you use packages, it will connect to the public repositories and it will download at runtime and it will pass the dependency onto all the nodes in the cluster. However, it is not a good practice when it comes to production. Typically, in case of production, what we'll do is we will actually pass using jars. When you specify the jars, you have to pass the relative path or fully qualified path for the jar file. In my case, I have the jar file under user itversity .iv/2 jars, then com.typesafe config -1.3.2.jar. Like this, I can actually pass the jar file name, and then I can actually pass the rest of the information, which is nothing but jar file and the argument. And hit enter. Let me kill this. Let me hit up arrow and let me show you the complete command. So this is the complete command. We have Spark Submit -class, the fully qualified class name with package.class name, and then jars. And I have provided the fully qualified path of the jar. The reason why you see under .iv/2 is if you actually go to the IntelliJ, whatever dependencies that are defined as part of the build.sbt, all the jar files which are downloaded when we add these dependencies, these will be copied to this .iv/2 folder. It is a hidden folder which comes as part of the SBT implementation. In that, there will be a subfolder called as jars, and then you will see the jar files like this. That's why we got the file there. And then the target Scala 2.12, which is nothing but relative path of my jar file, and then the argument, which is nothing but dev. Before running this, let me open another tab and then go to research data. Let me see the output directory here. Okay, I know why. So it should be cd home directory research data EMR demo, then retail DB. Let me delete this folder. Even if the folder exists, it will overwrite, but I just want to make sure that there's nothing here. Now let me run this. Once it is executed successfully, you will see the output here. It might be still running. Now you don't see that exception immediately, which means it is taking the resources to process the data. Now it have executed successfully. Now we can see the folder here. So we have validated locally, and we should be able to deploy to whatever target cluster we want to run in. Now it is time for us to take it to EMR. So let's do the recap of EMR, and we will see how to deploy this in EMR. Before that, there is a question from Jajati. I hope I'm not mispronouncing your name. He or she is asking, does SBT version matter with respect to Scala and Spark version? I don't think so. Earlier, I was under impression that it matters, but it is just a build tool, and hence it should not have much of an impact. If it is with older versions, they might have addressed lately. I have tried with multiple versions of SBT, and I don't see any issue there. Okay. So that being said, now let's go to the next step. We have validated using ID. We have built and validated jar using Spark Submit locally. We will not be able to run this in our labs because the Spark version is 2.4.4. as we are trying to set up on EMR. It might work or it might not work. If you want, you can give a try and you can give me the feedback. As this is for EMR, I'm not getting in there. But in case if any one of you want to learn Spark at a very low cost, we have our labs. You can sign up for our labs and you should be able to practice. Now let's upload the jars to S3. So I'm going into AWS console. Let me go to the services and let me pick the S3 here. Okay. As I have mentioned to you earlier, we will be using two buckets, one for jars and one for the data. The data bucket is itversity data, and the bucket for jars is nothing but BD Cloud demo. And the jar files which are built is not here. So what we can do, we can go to the, so I'm using a web console of S3. You can also use AWS CLI to copy the files into this bucket, but to keep it simple, I'm just uploading through web console. You can see that we can drag and drop files here. So let me go to the location where I have the files. So we need to have two jars. Even though we have built only one jar for the application, we need to pass two jars because typesafe config will not be part of our EMR cluster. So we have to upload the typesafe config also. Otherwise, it will not work. Okay. So first, let me drag and drop the main jar. So I'm going to itversity. So my project is under itversity projects. Okay. In projects, I have a folder called as internal. And as part of the internal, I have created this Spark 2 live demo today. So I'm going in there. The jar file is under target scala-2.12. And let's pick up this jar file. Okay, I have double clicked. I should not have done that. We should not double click, but we have to drag and drop here. Now we can say upload and it will be uploaded in no time. You can see this Spark 2 live demo blah 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 .jar here. We also need to upload the typesafe config. So let me go here. Let me go to my home directory because if you recollect, it is under .iv2 folder. So we have to go there. It's a hidden folder. If you are using Mac, you might not see the hidden folders directly. For that, you have to use Command Shift dot. If you hit Command Shift dot, you will be seeing the hidden folders. Now I'm hitting Command Shift dot to toggle, and I can't see the hidden folders. Now if I say Command Shift dot, I will be seeing hidden folders also. And the hidden folder which we are interested in is nothing but .iv2, which have jars in it. So let's expand the jars and let's go to com typesafe config 1.3.2.jar and let's drag and drop here. It will be copied when we click on upload. Now both the jar files which are required for running our code is in S3 bucket. I will explain why we are doing that when we get there. Also, let me go to S3 bucket itversity data. And let me go to EMR demo. There is a retail DB folder and daily product revenue folder already. So these are created when as part of my R&D process. So let me go to itversity data again, and then let me go to EMR demo. Let me delete all these folders and files. Okay, now it is clean. Once the program is successfully run, we will see the files and folders here. One folder, which is nothing but a retail DB, and then daily product revenue, another folder, and then we will see a few files over there. We will come back to this after we run our code. Now let's get back to the material. Now it is time for us to get into the EMR. So it will take another half an hour. Already we are very close to 1.5 hours, but we might have to extend for 10 to 15 minutes more so that we put a logical end to this. So let's go to the recap of setting up of the cluster. So the way you can actually set up the EMR cluster is by going to aws.amazon.com. You have to log in. And then you either can click on EMR if it is in recently visited services. If you don't see here, you have to go to analytics and you can click on EMR here. And you should be able to create the cluster here. Okay. So let me create the cluster here. I'm not going to create the cluster now. I'm trying to recap about how EMR cluster will be created. Typically, once you go here, you will not see all these things. These are my playgrounds or scratch pads, which I have tried for this demo and for others also. So you might see some other window which will give you some direction about how to take care of creating the cluster and all. The main thing is create cluster button. Once you click on create cluster, there are two options. One is quick options and second one is advanced options. So when it comes to quick options, you have option to use either cluster mode or step execution for launch mode. And then when it comes to software configuration, there are pre-assorted choices. There are only 4 choices. One is core Hadoop, second one is HBase, third one is Presto, fourth one is Spark. Depending upon your requirement, you can choose whatever combination you want. And then when it comes to hardware configuration, you should be able to choose the configuration of each and every node, number of instances, out of which one will be master and rest of the one will be core nodes. And you should be able to create the cluster. It will create cluster within few minutes. If you want to have additional capabilities while creating the cluster, then you can go to advanced options. When it comes to advanced options, it provides all the tools that are available as part of the EMR. You can choose the appropriate release, and based upon the release, whatever is available will be shown here. You can choose whatever you want for your purpose. Then if you want to overwrite any properties when the cluster is coming up, you can add those things here, or you can also load JSON from S3. You can do either of the way. And then you can also configure steps here. We have seen steps with quick options also. If you want to have steps as part of the advanced options, you can do so as well. However, once the steps are completed, typically when you use advanced options, the cluster will be up and running. It will not be terminated. However, if you want to auto terminate, you can choose it here. Cluster auto terminates. You can add multiple steps. After all the steps are completed, instead of cluster entering into waiting state, it will be auto terminated. Then if you click on next, after making the choices, then you can actually choose the instance group configuration. Either you can choose uniform instance groups, which means all the worker nodes will be of same type, or you can also say instance fleets. So if you want to just get the capacity from EMR, it will and if you choose the instance fleets, whatever type of servers that are available, it will pick those servers, and from there it will even with Cloudera or Hortonworks, there is a concept of groups, instance groups. So it will use that concept of instance groups. It might pick up different configurations, or it might pick up servers with different configurations, and it will create fleet with each and every configuration, and it will try to provide you the required capacity to you. It all depends upon what you want to use, depending upon your workload and all. For now, I'm just limiting to uniform instance groups. If you want to do some research, you can do research on instance fleets. Then if you have multiple networks, you can choose the network here. When it comes to here, we have 3 different types of nodes or servers. We have masters, cores, and tasks. If you want to leverage auto scale features, where you can get more capacity when you want to process the data, and if you're not processing the data, if you want to terminate the servers which are not being used, then you have to configure task servers. Then task servers will be only used for processing the data. They will not store the files, and they can be terminated whenever you are not processing the data. Core contains storage also, and when you create a cluster, when you keep it up and running, and if you have cores, you can actually leverage the HDFS that is deployed on the core. And you should not terminate the core instances. If you terminate the core instances, it might make your cluster unstable. When it comes to master in advanced options, you can have multiple masters also. If you want to have high availability of your name node or resource manager, etc., you can have multi-master setup, and then you can set up the cluster. But for step executions or for lightweight or less frequent jobs where you don't want to keep the cluster up and running, it is enough to go with quick options. But if you want to keep the cluster up and running based upon different workloads you have in your environment, then you have to consider advanced options. I will try to conduct another session about actual usage of these things at a later point in time. For now, due to the time constraint, let's move on to the quick options. Let's give the cluster name. The cluster name is Spark2 live demo. So as I have mentioned to you earlier, EMR clusters are typically ephemeral, which means they don't maintain any state. The file should not be stored in EMR. The jars should not be stored in EMR. That's why we have configured S3 for that. But once the job is completed, as the cluster is down, the logs will also be gone because the cluster is not persistent or permanent. So for that reason, if you want to troubleshoot the issues, once the cluster is or once the jobs are completed, you can enable this logging and you can provide S3 bucket for logs also. That way the logs for your jobs that have ran in the EMR cluster will be preserved in that location, and you should be able to troubleshoot the issues by going in there. So it's a good practice to use logging. So let's keep it like that. And in this case, either you can launch cluster mode and you can submit the Spark job the way we have submitted locally using Spark submit command, or for today's demo, I'll be using step execution. We have to choose the step. As we are talking about Spark, it is Spark application. Then we can go to configuration. And now, first you need to understand these different aspects of this page. So step type is Spark application because we have chosen it is grayed out and we will not be able to change it. And here we are trying to get daily product revenue. So you can give a meaningful name for the name. Deploy mode, either we can run in cluster mode or client mode. In this case, I am using client. Okay. Now, if you recollect what we have done, we have used the Spark submit command, and we have passed this -jars, -class, etc. So these are nothing but Spark submit options. Arguments are nothing but program arguments. So the argument in this case will be prod because we have defined all S3 related properties in prod properties in typesaf config, right? That's why we have to pass the argument here. And when it comes to Spark submit options, we have to provide class, jars, and also probably master just to be safe. So we can say master yarn, okay? And then we can say class. The class is nothing but retail DB get daily product revenue. I think the backward slash at the end is optional. You might not have to pass when you use this Spark submit options. You can give a try, and if it is failing, you can remove or add in case if they are required. Now we also have to pass the jar files. So I have already uploaded the jar files into S3 bucket. It is nothing but S3 : / let me go to the S3 console here, Amazon S3 BD Cloud demo, and then this is the jar file name. So let me see if I can get the path here. Yeah, let me copy this name. So it's under, yeah, let me do this. Let me copy this. It's under BD Cloud demo. So I have to specify that here, BD Cloud demo, paste it. It is the typesafe config jar, and we have to pass the application jar also. Here we have passed as target Scala 2.12 blah blah blah. In this case, we have uploaded this already to S3 bucket. So we just have to say S3 : / BD Cloud demo and the jar file name. The jar file name is nothing but this one. This is the path in AWS as S3 is also AWS technology, it can easily connect to that and it will be able to process the data. And finally, action on failure. If you want to keep the cluster up and running if the job fail, or if you want to terminate, you can choose it. So continue is it will go to the next step and it will keep on running. And once all the steps are done, it will typically terminate. Cancel and wait is if the job fail, instead of terminating the cluster, it will just cancel and wait so that we can troubleshoot the issue and probably resubmit the job. If you want to terminate the cluster, in case of failure, you can choose terminate the cluster. I will keep it as continue here. So it will execute all the steps if there are multiple steps, and then finally it will terminate. In this case, as we have only one step, after that one step, it will be terminated. So I can add it here. And then when it comes to instance type, let me choose m4.large. Sometimes these instances might not be available, and hence jobs might fail depending upon the availability of instances. So far, I have good success rate with m4.large, so I'm using m4.large here. And then I can say create cluster. So what will happen? It will provision the servers from AWS. They're nothing but EC2 instances. And then it will deploy the EMR software on all the nodes in the cluster. In this case, I have specified 3. All the 3 nodes will have all the tools that are required for running that Spark-based step. And then it will run it and it will terminate the cluster. You can keep track of the progress by going through this window. I have covered all these details in a lot more detail as part of the course in Udemy, where I have explained about AWS and then EMR and then Scala and Spark. You can take that course and you should be able to understand all the aspects of this. But I will cover some of the key things here. You can go to hardware and you can see what is going on. As of now, it is not started yet. It is just searching for the servers. Once the servers are available, it will change the state. So let's refresh this. And it will take time. It will take at least 5-10 minutes. Meanwhile, what I will do is I will actually go through my earlier run and show you how it will look like once the job is submitted. So as the cluster is terminated, the status you can see is terminated. If it is success or not, you can go to the steps and you can see whether it is successful or not. It is saying completed. You can also view the logs by clicking on this. If there's any errors, you can click on errors. Okay, there seems to be a pop-up blocker. Let me click on this and you can see what is going on here. So it was in accepted state for a long time and then it went into running state, and it seems it have ran successfully without any issues. You can see the logs here. So this is how you should be able to review the logs, and if there are any exceptions, you will see those exceptions here, and you should be able to troubleshoot and fix the issues. Let me explain how to get into these logs because it is very, very important for you. Once the cluster is terminated, you can go into the cluster. Here we have used the step execution. So if I go to the steps, okay, it is saying completed. Typically, if there are any exceptions, it will say failed rather than completed. You can also expand here and see what is the Spark Submit command used. So the deploy mode is client. The class is retaildb.get daily product revenue -- jars. This is the jar file name which is passed -- master yarn. And then this is the jar file which is used, and also the argument. The complete Spark Submit command can be seen here. And then if you go to view logs, you have controller, you have syslog, you have standard error and std out. You can review all these things. Typically, if there are any exceptions, you should go to standard error and you should be able to see the details. This is how you should be able to troubleshoot the issue. Even if you use log4j and if you log as part of your application, those details are also typically seen as part of this. And also I have shown you the Spark application logs. We also have something called as Hadoop debugging, which is by default after setting up the EMR cluster. That is another step which will be executed even though you haven't explicitly specified that. You can also go through that to see if there's any issues. It doesn't provide a lot of information here. Okay, so it is very, very important for you to understand this aspect. It will help you a lot in troubleshooting the issues. Okay, hardware to make sure that whether the servers are provisioned properly or not, and then the steps and go to the logs to troubleshoot the issue. You should also have a very focused approach, and you should diligently see how the Spark submit command is built, whether the path of the jar files are correct or not, whether the appropriate jar file is used or not, whether the arguments are passed or not. And if there are any issues, you also need to check whether the properties are defined properly or not for a given argument. All these things should be emphasized. That then only you should be able to troubleshoot the issues. Otherwise, you will not be able to identify where the issue is. That being said, now let me go back here. Sorry, not here, but let me go to clusters. It is still in starting mode. I think it is, yeah, now it got the master node. We can actually go to hardware and see where it stands. So master is in bootstrapping, which means after server is provisioned from the cluster, sorry, not from the cluster, but AWS data centers, it will do some bootstrapping. As part of the bootstrapping, it will try to set up all the jar files and all those things automatically for you, and then it will take it further. Okay. That being said, I'm not going to wait until this is done because I have already covered how to troubleshoot if there are any issues. I will move on to the questions. I will take the questions. While I take the questions, I will let the job complete. If job is failed, we will troubleshoot the issue. If it is successful, we'll just validate that the files are created in the output directory in S3, and then we'll wrap up the session. It is just a matter of under 5-10 minutes. So there are few questions. Jajati have asked, does SBT version matter? Yeah, I have already answered that question. Now Vinod is asking, can we use type-safe libraries for Python-based applications? No, you can't. You need to understand that Python and Scala are two different beasts. Whatever you are doing in Scala, there might be alternative in Python, and most of the Scala-based things will not work in Python, except for Spark-based APIs. Okay, because the Spark-based APIs are built for data engineering, and they have support for Java, Scala, and Python. Okay, you might be able to use type-safe libraries in Java-based projects because Java and Scala belong to the same family, JVM-based programming language family, whereas Python is completely different interpreter-based programming language. So one of the alternative is config parser, or a Python script itself can be a configuration file. So you can define a dict object as part of a Python script, and you can import the Python script itself as part of your program to control the runtime properties. Okay, so you have to have that clear distinction between Scala and Python, how you should do these things. Except for Spark, most of the other things will be different between Scala and Python. Okay, any other questions while this is running? As I have mentioned to you earlier, if you like the content, please click on the like button and also share if you want to share with your friends. If you want to learn more basic stuff about Scala, Python, Spark, etc., you can go to the same discuss material which I have shared as part of the communication. I'm also pasting in the chat. You can go to this link, and if you go to the beginning part of this blog, I have given some quick links. You can actually be part of our mailing list to get the notification for our live sessions like this. I will also start creating some working sessions where we will work together, and I will give some time for you also to perform certain tasks. And if there are any issues, I will even troubleshoot and fix then and there. So if you want to get notifications for the working sessions or live demos, or the coupons on Udemy, or job related information, etc., please stay in touch with us by clicking on this first link. Okay, it will take you to this where I will be only asking for your name and email. Other than that, I will not be asking anything. Then if you want to sign up for our courses, you can go to this link. You can see the coupons. For now, we are using this page. In future, we might come up with another type of application where you can purchase the courses. But for now, you can use these links and purchase the course in which you have interest. And if you want to get your hands dirty with the proper environment, you can go to labs.itversity.com by clicking on this. You will get access to a 9-node cluster where we have Scala, Python, Spark, Hive, HBase, etc. Let me quickly walk you through that, what you will get, so that you have fair idea before signing up. There are a few questions I will just take in a moment. You will also get access to this. We are also conducting weekly sessions to onboard the new customers for us. And if you go here and if you click on hosts, you can see what all we have in this. There seems to be some issue. Let me see what is that. The Spark history server is down. Let me start it. You will not be able to do it as a user. You will be getting only read-only access. But as I'm a administrator, I'm able to start this. And if you go to the hosts, you can see that there are 2 gateways, which are 16 cores and 64 GB RAM, and then 3 masters, and then 5 workers. And these 5 workers are 8 cores and 32 GB RAM, which means we have almost 160 GB capacity and 40 cores in this cluster. So you will actually get proper exposure. Okay. Now let me get into the questions. Okay, let me get here to see where we stand. Yeah, now the cluster is terminated. First, let us validate whether the files are created for us or not. For that, I am going to Amazon S3, itversity data. So first thing what you should do, even the run is successful or not, you should go to the output directory, which is nothing but itversity data. And then I think, let me check. I have to go to application.properties, EMR demo. Where is the EMR demo? itversity data. Interesting. Let me refresh this. I have seen earlier. I didn't delete the EMR demo. Let me zoom in a bit. Yes, S3, itversity data, EMR demo, retail DB. Let me go here. Interesting. I think it has failed. Let us troubleshoot the issue. Okay, EMR. Let me go here. Hardware. You can see that servers are provisioned. Let me go to steps. Yeah, that's the problem. So let me go to it is saying where lib. Okay, probably as part of my Spark submit, there might be an issue. Spark submit, yeah. The reason is we have that backward slash, due to which it has failed. It's my bad. Okay, if you look at the previous run, it doesn't have that. So let me run it once again. That way you will also be refreshed with this. So Spark to live demo. Okay, we have to choose step execution, Spark application, configure. We have to choose client, daily product revenue. Ideally, it should have validated here itself whether we are passing the Spark submit options properly or not, but it didn't do that. That's fine. Okay, now I already have it in the material. So let me go into the material and let me copy those 3 lines. Okay, so you can see how it have helped by just focusing on the Spark submit command, which is submitted, because there is a slash in between. Because I have added slashes to end the line here, it failed. Okay, that's the only reason it have failed. Now I can say S3 colon BD cloud demo, and then the jar file name is nothing but this one, and the argument is nothing but prod. And let me add it. Let me choose m4.large. Okay, and let me create the cluster. So there are few questions while it is running. Jajati is asking why it's taking long time to execute Spark job as compared to cluster. Yeah, here, if you really understand what's happening, first it is provisioning the servers. It is not a existing cluster. If you have a cluster running all the time, then you have to pay for it whether you are using or not. Here it is not giving you resources on an existing cluster. It is actually provisioning the servers from AWS, which are nothing but EC2 instances. Then it is installing the softwares on top of it. Then it is submitting the jobs. So that bootstrap time is significant. Okay, there is a way to work around this and get the things a bit faster. For that, you need to have a minimum size cluster running all the time, and then additional task nodes can be added if you use auto scaling features of AWS, which is out of the scope. But that is the reason why it is taking a bit of time when we actually use EMR cluster with step executions. Now, when it comes to implementation, let's say if your SLA is 1 hour to process the data and save the data somewhere, then you have to make sure that you plan properly to include this overhead also, the overhead of bringing up the cluster and then processing the data. And termination is not that important, but at least processing should be done within that 1 hour. Okay, so let's say you have window of 12 to 1, and if it is taking 10 minutes to spin up the cluster, which means you have only 50 minutes of time to process the data, and you need to ensure that you define the cluster configuration to complete the processing within that 50 minutes of time. Okay, you might have to use a bit additional resources to catch up with that 10 minutes you have lost. I hope I have answered your question, Jajati. If you have any follow-up question, you can ask. But I hope I got your question and answered correctly. If I'm wrong, or if your context is different than mine, just highlight that as part of the chat and I will take it further. Chetan is asking, how can we plan to scale up the application to make future enhancements in terms of adding new functionalities with the new external jars or libraries? So that is technical as part of the build process. You have to plan your build process accordingly. Chetan is asking, is the itversity lab built on top of AWS or self-managed servers? They're self-managed servers. We are not using AWS EMR. AWS EMR might not give the interface like Ambari. So we actually provision the servers from a data center, set up the cluster, and then we are providing you the subscriptions. So if your organization want to do a POC or anything, let us know. We can do the POC within 2 weeks, depending upon your problem statement, and we can actually lay the foundation for the project, and we can take care of all the things that are required. Thank you, Rags. The question is, Alok, how to automate the production job in AWS EMR? Can it be done using Airflow itself? Yes, Rags, you can either use Airflow. Airflow have plugins to connect to AWS and submit the jobs, or AWS itself have solutions for that. You can build pipelines and as part of the pipeline, one of the steps will be to spin up the cluster and submit the job. Yes, it is possible either by using Airflow or LinkedIn's Azkaban, or AWS itself have solutions around it. I think it is cloud pipeline or something. I don't remember. You can Google around it. You will be able to get the information very quickly. So once again, I'm reiterating, if you guys like this content, please click on the like button and share with your friends. It means a lot for us. And also, if you want to get notifications in our future sessions or future live demos or working sessions, you can actually go to the link which is provided as part of the blog here, and we can take it further. So let's see if this is completed. It is still in starting state only. Sometimes the information which you see as part of this might be a bit behind. It might not be the current information. It might be up to a minute behind. So let's see where we stand with respect to steps. They're still pending. Meanwhile, let's validate our Spark Submit command, whether we are using all the information correctly. Yeah, everything seems to be correct. This time it should work without any issues. Unless there are typos here, it should run. Racks, definitely we will work on AWS Glue, but as of now, I'm in Bay Area and I'm consulting, and I don't have too much of time, but I have AWS Glue in my mind. I also want to explore to build expertise in our data engineering center of excellence. Glue is one of the key skills which we want to build for a period of time, but don't expect around Glue at this time. It will take some time. Also, as I have mentioned to you at the beginning, if you are in a decision-making position and if you want to do a quick POC, I'm even open for pro bono consulting. No matter where your project stands, I can definitely do the review, give some inputs to improvise on the process or whatever it is, and then I can identify the anomalies in the architecture and provide some inputs. If the project is not started yet, I can start discussions at the requirements level itself, and then I can have a roadmap. I follow lean methodology, so 1 or 2 people will be involved at the beginning. We will focus on MVP first. We will have whatever is required for the MVP, and then we can have a plan where the client and our organization can work together to actually build the solution. And also, as part of that process, we will build enough expertise in the client also, so that either they can support, or once the project is developed or delivered, we can take over as part of the managed services. So we will make sure that we work very closely with the client. That's the differentiator when it compared to larger enterprises, where things are a bit political and hidden between the client and the vendor. We will primarily focus on working very closely with client. If client is very tech savvy and they want to take over a period of time, but if they want to collaborate with us in the longer term, we will make sure that enough skills are shared with the client to streamline the process of issues in future. So our approach will be a bit different, being a startup. So that being said, let me go here once again and see where we stand. Yeah, now it is completed. It's a good sign. Now I can go to S3. Let me refresh this. Now you see EMR demo folder, retail DB, daily product revenue, and the JSON files. There are 2 JSON files here. So we have processed the data which is in S3 bucket, applying whatever logic is required for daily product revenue, and we got the output in JSON files into this location. Okay, and the cluster is also terminated. That's it. We can wrap up. Let me know if you have any questions. Otherwise, we will just wrap up. And thank you very much for joining the session. You will see these kind of sessions going forward, at least from the month of March till the end of May, quite often in US time, because I am in Bay Area till end of May at the least. And be prepared for it. And if you want to get the notifications, as I have mentioned to you earlier, just sign up for our mailing list and we can take it further. Also, if you want help in consulting or data engineering services, I am there for you. Okay, thank you. Bye.